done in primary that essentially dies on the vine, and a lot of work gets done in the practical sense that is like, oh, well, this is how we're going to mass produce. But you really need that flow of ideas and information and innovation through the system. And we always refer to it as an ecosystem for that reason, because I think it's important. And I just wanted to add that as a bit of a note. I'm just going to give a very, very brief overview. So I guess I'll also set you guys up for doing the right thing or performing how we hope. We're going to do three presentations. Keep them short, keep them brief, who we are, what we do, some of the collaboration work, and then get into a discussion with you guys, hopefully. And we've planted my colleague Pia here with some questions, but preferentially they would come from you, and we'll talk about how this is going to work. So the Applied Research and Innovation Services at SAIT has basically 5 general areas. It's Green Building Technologies Access, that's myself. The Center for Energy Research and Unconventional Technology, that is largely renewable energy systems, et cetera. Center for Innovation Research and Unmanned Systems, that's drones, that's what Wade will be speaking to specifically. And an Innovation and Research in Applied Manufacturing and Materials. And that is really the group that tackles the complex question of what is it and how does it behave. And one of the things we are really emphasizing in SAIT strategic plan and our own work is how do you bring all 4 of those together? And in order to help bring that all together, we have an independent research group which does a lot of the kind of overview, oversight, and collaboration systems. So we are living the life that we hoped, which is trying to build that more comprehensive system to really tackle complicated problems. Getting into GBTAC specifically, so our mission is pretty simple. We want to lead industry in building greener buildings, full stop. That means you do commercialization, that means you do research, that means you do monitoring, that means you do a soup to nuts, as they would say in the business system for how to build better buildings. We do have a research center that includes offices, and probably more important to our collaborations with WaveTech, we have our own testing facilities. So we do everything from structural testing to thermal testing. We'll talk a little bit about those services, but clearly we have the ability to not only build things, but fast prototype, investigate, and test other people's ideas. And I think that's, again, when we talk about that comprehensive research ecosystem, that's what we're talking about, is the conceptualization from idea to testing to prototype to commercialization and execution and scalability. We have several research themes, and I'm going to add an overlay at the end of this, but the first one is our building science. If you are talking about how to keep water out, heat in, all of the things that make a building, what glass looks like, how does it behave, how does the structural systems work, that is in the general area of building science and the building envelope. That includes retrofits, that includes new construction, that includes testing, of course. The second one is specifically related to energy, and that is energy use in buildings in this context. But again, we always hear the buzzwords of net zero energy. Again, I say this as a former architect. I love that term because any building's net zero ready. But tell me how you measured it, tell me how we're going to quantify it, tell me what that means in execution and design. Because that's where it becomes an interesting problem, in my opinion, and I think that's really where it gets fascinating. And that includes all of a sudden, if you're going to tell me something is net zero, well, how do I monitor it and measure it to make sure it actually did become net zero? All part of the work we do at GBTAC. And the last one is, and this one relates a bit more to the work that Pablo does, so that's the kind of loop that brings us all together. We call it architectural ecology, which is essentially all the things that deal with site use, water maintenance, water servicing, water quality, water reuse, all of those things. But the ecological nature of the building, for biophilic design, all of those wonderful phrases, and a very interesting area of research right now, because I think the idea of building a building like we did in 1976 has finally left the building, and it's good to see it. Like Elvis, it's good to have a go. One of the other kind of tangential things that we do because of the research we perform at GBTAC is we do a lot of education industry training, and I think that's a big part of, again, we've kind of put this together to highlight how we have in the past and will continue to work with the city, and I think that is where we're headed next. And I did this in a really simplistic form for a reason, because I'm much more interested in talking to you guys about what this means. But I think we have at least three areas that we have commonly collaborated with the city, and that's training for staff and industry. We are excellent trainers. We're an educational institution. I would be ashamed to say we don't train well. We do. We train very well. But we can also talk about how to do this on a different way, which means not only taking industry and saying train them in X, Y, and Z, but getting them to think in a different way and opening up the ability for them to explore their own ideas in a constructive, practical, research-oriented way. Case studies and student integration. Again, one of the things that really attracted myself to the Wave Tech Center is the idea of using students as a kind of a fast prototyping service. And I'm going to deviate off the script for just one moment because I think it's important. But the idea of being able to use student work and student projects as being a research service, a prototyping service, and a data service is incredibly important. I cut my teeth, you know, it's been a long time ago, but I still work closely with a lot of colleagues in consulting. Consultants are wonderful at providing you the solution they know, because that's what they do well. That is why they get paid well. They provide the solution they know fast, effectively, and on time. However, if you are interested in innovation, you start needing a little bit more of a sophisticated methodology that involves things like an escalation of ideas. So for instance, one of the things that we've kicked around just kind of in loose format, using things like student capstone projects to say, here's a problem at the city, give us 9 ways to solve it. And we can evaluate those 9 ways and say, okay, from the 9, these 3 are worth exploring in greater depth. These 2 are worth actually doing a prototype on. This one's worth sending to an engineering firm or an architect to say, let's get it built. And that ability to take an idea from broad conceptualization is, I have a problem, to here's a series of solutions you can employ, to here's the solution we've decided on for all the right reasons, that's a really powerful tool. And I can't emphasize enough how what we're doing here today is the start of how you essentially do idea exploration. And that's really powerful to me. And so I can all read, I don't know, you think of it what you will, but we've worked with the city a lot in the past and we'll continue to do that. I think this just gives us a new and interesting way to further that relationship. One of the last things I just want to cover before I hand off is, I think it's very important to talk about, whoa, I've hit a button that's gone crazy, sorry. But the idea, yeah, fair enough, man. That's right, damn you, Freddie. What I was gonna say though is also the ability to foster partnerships. So again, being a major educational institution, partnering with the U of C, partnering with Innovation Alberta, partnering with industry, partnering with the city, let's identify the common problems, prioritize them in a way that makes sense to what benefits the people and the public and everybody, and use the right partners to get the right solution sets explored in a comprehensive fashion. That's kind of what gets me out of bed in the morning, and I hope that's what gets everybody else out of bed in the morning too. With that, I've probably talked way too long, and I'm gonna hand over to my friend Pablo.
Thank you, Justin. And yeah, I'm just gonna go as processed and quick and efficient as I can. I think I just want to add, as my colleagues mentioned, the focus or the core of the scope of what I do is talent development. From the point of view of the students, the critical mass or the meat, the excitement piece on my end is the students. I directly steward 3 core programs under my portfolio. Water, integrated water management, environmental technologies, and chemical laboratory technology. So I kind of summarized the core areas of expertise in my team around those 3 areas, all wrapped around environmental sustainability or sustainability at large. I know sustainability could mean many different things. I usually frame it as sustainability, aero, environmental sustainability, aero, well, 3, right? Water, environment, and chemistry. All right. Okay, so I'm just gonna follow exactly the template that Justin used. Very quick, as I said, the stewardship of 3 core programs. We collaborate. I love the concept of sustainability. I always say, well, what can we use in terms of opportunistic concepts so that we can bring umbrella values to many different stakeholders and kind of have this relatedness very quick. Everybody can understand what do you mean by sustainability? Well, sense of place, preservation, beauty, values, right? We have, because of that, we have constantly partnership both regionally and internationally. And as I said before, like 75% of my portfolio is about managing the team. What do you mean by that? Well, think about faculty, think about students, think about techs, think about facilities around that. And we want to leverage all these facilities as well. But 35% is very broad and open-ended. It means research and innovation. And that's fascinating to me because it allows me to, how can I use these components of education in terms of students and programming that we can feed through that 35% of innovation and research to further advance the mandate of what we have. So I put in some slides that probably Wade will find familiar around drones. Okay, so similar, it's a big family. Believe it or not, in the School of Energy, it's the smallest pod of portfolio. I am fascinated, I'm blessed with great caliber of expertise in many different areas of expertise. But if I can summarize very quickly for you what kind of facilities, similar to what Justin said, we have probably one of the best water treatment lab facilities in the province. We have a whole, and I love one of the sheets around digital divide because that's something that we as a team believe very at the core. We have a virtual reality facility that's basically tackling digital literacy. And for the chemistry, that's probably our most comprehensive suite of facilities, analytical instrumentation, benchtop, a lot of different areas, and field. Because as you can say, for water and environment, probably 60% of everything that we do is outside. So Internet of Things, air, soil, water, groundwater, surface, anything that you want, we have to have that, not only as part of our mandate for research, but also competency development. So we do have a lot of field schools. Our students spend a lot of time outdoors learning how do you measure that, not only to hug the trees. I'm just gonna use this. What?
It's telling you to slow down.
I think it's, oh, wait. No. Right. Okay, very quick. All right.
It's going to take a sec. We're just moving in. We're a little bit beta, and our internet is a lot of duct tape right now.
Oh, right, I see the screen changing here, but not in the, okay. I could just read these in here, and everybody can imagine.
Yeah, that's right. Let me paint a picture. Yeah. On the video feed, it'll look great.
Oh, it will look great?
It'll be on, it's on page, but just the stream shares is.
Okay, well, if I look at the slides, I can just tell everybody because everything is summarized in here. So the themes, as I said before, one of the core themes that we have is water management. So you can see, well, we cannot necessarily see that, but as I mentioned before, we have from the water treatment side, water and wastewater treatment, collection and distribution. We have great partnerships with the city from many levels, not only in terms of research and capstone projects, but also practicum. So we constantly work and collaborate with your colleagues. We also have, as I said, we have the water treatment side. We also have the water monitoring and sampling as well. So we have equipment and training around that area. From the environment, right now, we just hosted actually one of the, in partnership with the city actually, a theme around food systems, in particular urban farming. So core of my team is very interested in food systems, so we are really exploring that area. As I said before, similar to water, anything that you can think of from the environmental sampling, monitoring, and analysis. from the field to the lab analysis and testing we have. And something that is relatively new, but it's a huge intersection for across these different disciplines is the digital space. Think about I love that there was a lot of mentions around 3D printing, 3D modeling. I love that, and one of the reasons is because that's an integral part, and Wade probably has that. Well, I know he has a huge piece of that from the drones point of view, not only from the analysis, but communication and engagement. Before I started working at SAIT, I realized that drones were a disruptive entity, not only because of, obviously it's such a cool tech, but because I realized that it was an incredible way to engage with the public with complex or complicated information, and that's the 3D space. So we have our lab of virtual reality has a suite for 3D modeling, and one of the projects that we had was to create an asset of 3D models for the library. I don't know if you guys are familiar in that world, but if you just look at Sketchfab, you just Google Sketchfab, you're gonna realize that all over the world, there's a whole community that it's all about 3D communicating. And you can find a bunch of assets from the City of Calgary there. Just Google Sketchfab 3D, well, no, Sketchfab City of Calgary, or Sketchfab Calgary, and you're gonna find a bunch of people that are geeks, or they're just digital enthusiasts, and they're just uploading their models. So when we pitch to the library, hey, we wanna have a landing page for SAIT where we can start placing that, because we wanna make sure everybody understands that it's so easy now to use 3D modeling as a way to, or as a proxy for the 2D world, because most of the times, when I realized that we had to mainstream that, is because one of my colleagues was showing me that for their assignment, they had like 10 pictures for a turbine or a valve. Rather than having 10 pictures, wouldn't it be easier just to have a 3D PDF and just have the students rotate and do whatever they want and really look at it in a good and fine detail? And people were like, well, I mean, how do you do that? And I think for me, it's going to the point of the digital divide. I mean, if you're not necessarily interested maybe you're a gamer or you like a little bit of tech, you're gonna think that those items are incredibly complex, or they're only if you have a very high proprietary technology. But everybody that now has a phone like this with 3 lenses can do things that 10 years, 5 years ago was like really unthinkable. Like you need a special type of software, but not anymore. As I said, just search for Sketchfab. Are you gonna realize that the 3D world is here in terms of the democratization or like the accessibility. So one of the things that my team has at a core is that's why, or hence the idea for a digital lab or a virtual reality lab is to mainstream that portion from the point of view of environmental sustainability, but everybody should have that piece as well. So there are 2 core pieces that we want to have: the digital literacy in the form of accessibility, and the second one is the open access and open source revolution. So the reason why we push so much in that area is because, as much as, of course, there is the reason for the copyright and accessing properly curated software or licensing for tools, there's a whole world like Wikipedia where you can have the veto for peer-to-peer of information like programming, like GitHub. So we want to make sure that our students, as part of the digital divide and digital literacy, they understand that there's a lot of really different, interesting, and very well peer-reviewed tools around the world that should be of use to for everyone. It just requires you. For me, in my case, for instance, it was just a fluke that I ran into something called R that is very well used now for data analytics. And it's almost like Python is the standard for data analysis. And it's an open source tool. And back in the day when I started using that, it was more anecdotal that I ran into it because I needed a tool, and every lab that I was going to used a different software that you had to pay for. So I found R. And I really realized now it's a very mainstream tool. So again, going back to the point of why we push for this digital lab, like a virtual reality in my group, from the point of view of environmental sustainability, is really trying to tackle the digital divide. And I don't know, Wade, do you think you can use the...
Just to be honest, like I said, it's the screen, it's not your computer. It's streaming here, it's streaming online, just not...
That's okay.
We dropped the internet at 9:30 and it hasn't rebooted yet. So I'll work on it
That's okay.
All right, do you want me to take over?
Yeah, take over.
Okay.
Right now.
All right, so thanks. My focus is on the drone center. So I already talked about the center name. We have two focus areas: applied research. So we're focusing on working with clients to solve their problems, and that could be small, medium-sized companies, all the way up to the big players, nonprofit, government agencies, whoever has a problem and comes to us. We are in a position to work with them, which is great. We also do quite a bit of work internationally as well, with partnerships in Germany, Switzerland, and several other countries. We also have a remotely piloted aviation training center. So again, as my colleagues mentioned, a lot of focus on student learning. So we do offer training in a larger platform, so platforms that are greater than 25 kilograms. So these are drones that are operating for 3 hours with up to 150-pound payload, running jet fuel. So they're not just your small drones you'll see at Best Buy. They're quite a bit more, much more rigor. There's a lot more maintenance requirements, so requires an additional training feel to it. And then SAIT is also well positioned in the aerospace industry in general. We have a School of Transportation, and within the School of Transportation, we have a 15-week RPAS, or in Canada we use the term remotely piloted aircraft systems, or RPAS. Other countries utilize unmanned systems or unmanned aerial systems, but in Canada we use the RPAS acronym. And we have that remotely piloted aviation training center. We also have the 15-week certificate program, and we also have an aircraft maintenance engineering technology program. So lots of different positioning in the aerospace industry. We also have under the School of Construction, we have a lab that's called the Connector Space, and that's really focused on capstone students. So bringing together capstone students to enable the adaptation of technology. So drones, survey equipment, anything that the students look for, which is great because we do take on capstones in the lab as well, but we just don't have capacity to take on more than 6 to 8 capstone groups per semester, whereas the Connector Space can take on 30 or 40. If you were to see the lab, it's on the 4th floor of the Aldred Center. So if you're going down 16th past SAIT, it's the building that has the flowy roof on the top. Really dynamic space, really, really high roof. And we have a number of drones ranging from, like I said, fairly cheap, $600, up to several $1.1 million drones. Thanks to the funding from Prairies Canada and NSERC. So we're really fortunate to have a really solid infrastructure of systems. We also foster professionalism, so making sure that our own staff are working in a professional manner, especially when we get to a mine site like Curl up with Imperial. We need to make sure that we're operating in a professional manner, and we make sure that our students are also focusing on that. One of the challenges that I used to be in the Geographic Information Systems program, one of the challenges was also convincing students that communication and professionalism is a really important piece of your day-to-day operation as a student. When they come to us to work on a capstone project or a practicum position, they learn pretty quickly because they realize if they don't act in a professional manner and they're at site with us, they would get asked to leave if that happens. So it makes it real quick. Also, we, as a institute, we do not retain IP, which is another advantage for clients working with us because we basically focus on commercialization. And there we go. There's our space. Thanks. Do you want to go back, Pablo? Anyways, yeah, so that's our space, really dynamic space. We actually have a second space, you can't see it, that is about the same size, but lots of excitement. It's like this space. I was here yesterday presenting as well, and it's just the energy is great. And when you have that kind of energy, it's hard not to enjoy going to work and getting some really cool things. That's just an example of a dashboard that one of our student groups built with Alberta Wildfire, and it's just a dashboard that streams in a number of real-time data feeds from different sources. And we have this pipeline that we're proud of. We bring capstone project groups in. It's a 4-month final project. Then hopefully we can hire a few of those folks as practicum students for an 8-month work term. And then either we hire those on as full-time, but ideally they would get taken by some of our industry clients, and often by the clients that they're working on the capstone with, which really works great. We have our own safety, and confidentiality is obviously a big role for us. I'm not going to focus too much on this, but kind of just gives you a sense as to what we're doing. We sit with our client, we look at scope of work, so we try to, what is the thing that they want to do? Set up really achievable objectives, break down bigger chunks into smaller chewable chunks. And we focus on choosing the correct drone, the correct sensor, planning operations and standard technical procedures, the regulatory environment. That's really important because as you get into the larger systems, you need to make sure you're doing things properly. And then lastly, our analytical framework. So leveraging machine learning, artificial intelligence, wearables like VR, AR type things, and just making sure that the data we collect from the drone and the sensor is actionable data that they can then make decisions with. And we'll often sit with the client before we start. So we'll sit with a geophysicist that's dealing with subsurface geophysical data and look at what software they're using, how do they actually work, like what's a day in their life, and then we reverse engineer from there. And that's that center one is a ground penetrating radar. So that can actually penetrate down to 110 meters, giving important data to clients, right? City of Calgary, underground infrastructure, if there's areas and you're not sure where the infrastructure is, it's a great tool to help support that instead of digging up a bunch of the land. Just connecting to the labs. So I mentioned this yesterday. We are fortunate to be part of the Living Labs. We do leverage the RPAS training area quite heavily. This has been a huge win for us because it's 20 minutes from our center. So instead of flying or driving way out of Calgary to find a place to fly, we can actually operate within the City of Calgary. That's a big draw for a lot of our clients, especially internationally, because Canada has lots of airspace. And we have access to a facility here, plus a dedicated area for flight operations. We also have a strong aviation ecosystem in Calgary, RPAS as well, and lots of collaboration. So I was presenting with another drone company yesterday, a service provider called Arium Analytics, and they agree. It's amazing that all these companies in Calgary are collaborating. We're not competing. We know that there's enough work out there, and it's a very collaborative model, which is super exciting. And then we have lots of great support from Transport Canada from a regulatory standpoint to try to do more things from a drone standpoint. Real quickly here, I'm just going to finish off with a few examples. So storm ponds and rivers. So 2 examples that would be applicable to Calgary. There are several others that aren't quite as exciting, like maintenance is a huge thing, facade inspection. You could start listing off probably 100 different applications that the City of Calgary could leverage drone technology. I'm just going to talk about river and storm ponds, and this is integrating 2 sensors. One is GPR, so that's the ground penetrating radar. That's our smaller drone that we test with, and this is it mounted on our bigger system. So that sits about 1.5 meters high by about 2.5 meters long. And that can give you subsurface measurements, and in this case, we were testing it on a river system. So to get the depth of the river, and also we wanted to see the bottom of the river, and I'll speak to why that's important. And what we did was we built a custom algorithm to automatically detect the largest signal, which is the bottom of the river system, right? So it looks at contrast. And on the left there, it just gives you that profile of the system. And then we also leverage an echo sounder. So it's a dual return echo logger. So it's basically continuously sending a pulse of energy down, and the sensor can record the speed at which it comes back, and then you can get water depth. The reason we've leveraged both is in this case, you'll see the drone flying along the water pond. What has to happen is the drone has to dip that sonar about 13 to 18 centimeters below the water, and then it's vertical, and then the drone pulls it along the water. In the cases of larger environments, larger ponds, if it's 1 kilometer by 1 kilometer, that's going to be a really slow process. So what you can do is lift it up and dip it every 20 meters or 200 meters, depending on the accuracy you need to achieve under the water. So the reason we're looking at both these techniques is the sonar works really well. It gives you, in theory, the bottom and then any sediment that's existing, so it'll give you 2 returns. But if the sediment is thick enough that it gives that one return what it thinks is the bottom, we don't know if the bottom is the true bottom. So the GPR is that we're pretty confident that the GPR is going to give us true bottom, and then the sonar will give us some different levels of sediment level. Ideally, they would match, and you'd get the sonar indicating the bottom and the GPR measuring the bottom as well. But in some cases, especially with some of the mining clients where there's quite a bit of sediment buildup, they need to know that what is the bottom and what is the sediment levels. And from a monitoring standpoint, this is important because you can start to look at when you need to dredge a pond, for example. We do a lot of methane detection and quantification work as well. So just an example of showing methane concentrations, we're using one of the sensors we're using is the OPLS sensor that NASA's JPL lab produced, and it's on the Mars rover. And we've also incorporated a few other sensors just to see the capabilities and what can actually do a better job of quantification. And then this is actually another capstone project where we were looking at back trajectory of wind, so looking at wind speed and a dispersion model of that methane concentration. And then lastly, I'm just going to speak to the medical delivery project. Importantly, this is with Stoney Nakoda Nation, so the communities west of Calgary, Eden Valley, Bighorn, and Minitini, or also known as Morley. And W21C, so that's the research division of the Foothills Hospital, University of Calgary, Alberta Health Services, Alberta Precision Laboratories, and the World Health Organization. And really what we were doing is leveraging all kinds of drones, so the smaller ones I showed you earlier, and also this is our heavier lift drone. Good scale picture on the left there with the diesel fuel container and the two pilots. And just gives you a sense as to, it's just an operation. So we are doing some delivery of medical supplies and devices to Stoney Nakoda. And our big wins, we deliver PPE, pretty straightforward. We were able to deliver PPE to the remote community. We also delivered test kits, so COVID-19 test kits. This is before the at-home kits were available. So we were able to deliver test kits to the community, have them simulated, administered, return them to the lab, and we determined that there's no signal decay. So in theory, we can send these types of things out to community, have the community stay in place where they're safe, have the test kit administered, and then bring those back to the lab. And it's great. We were written up for a few of these projects in the American Journal of Infection Control, and the reason I bring that up, it's just nice because academic or technical colleges aren't always known for publishing, but it is one of our focus areas. Is if we're doing a project, we're applying enough rigor to make sure that if we need to or want to, we can actually apply to or submit journals for various applications. And then also the last three I'll just speak to is communication with mentor. I think this is our secret of this project is we actually are integrating physicians at the Foothills Hospital into this project. And so the PPE and COVID, no need for a mentor, right? The last three, you do need the mentor. So the first one was delivering a Stop the Bleed kit. So that's gauze, clamp, and a tourniquet. We do operate in winter. It's not always just nice weather. This is in Ribbon Creek in the Kananaskis. We deliver the payload container. It's like a Tim Hortons box. It's quite light. The person you'll see will open the payload container, and Kristen will actually place her phone that she had called 911 on the tripod that's in the payload container. And she is being telementored or taught by the physician on how to apply a skin clamp. And you'll see that in a second here. And she'll have the phone on the tripod on the right. And she's applying the skin clamp. And we have a custom Zoom client. And the physician's actually teaching her, telling her how to do that. And we're using Starlink, so connectivity isn't an issue anymore. Again, another journal publication for that one. That was very exciting. And then we also did an ultrasound. So delivered an ultrasound to an ultrasound-naive patient. He was able to follow the instructions from the physician, unpack the ultrasound, place the jelly, position it, turn it the way that he needed to turn it. And so all this is being documented on our procedures, so we're perfecting the process. And then lastly is our current project where we're actually looking at, asking you the question, what is your responsibility to help someone dying from acute respiratory distress? So if you're at a remote access site with a colleague and he or she suffers from a collapsed lung, falls, gets impaled, and cannot breathe. What are you able to do, right? So what we're trying to do is, or maybe you're alone and this has happened. What we're trying to do is we have an emergency procedure built. So we have, I'll just pause this real quick. We have the emergency management drone, that if it's a scenario where there's a motor vehicle accident or maybe there's a train derailment, we'll send a drone in first to give situational awareness of what's happening. And then the second part is the medical delivery drone. And the idea behind this video is this is a simulation of one of our patients pretending to call 911. So that's one of the drones that we would use with a smaller payload container. So the idea is the person called 911, we can extract those coordinates from the phone, send the drone out to deliver the payload. This is just, this isn't actually a real test, this is just the simulation. So the drone stays high, so it has good radio connection between the two locations. Oops. So that was, I don't know what, I'll just finish it here. So you can, that's actually the live ultrasound as he's doing it real time. And the last part of this is he's being self-administered, teaching him how to actually do a chest tube intubation. So where to landmark on the rib cage, 3 centimeter incision. The part that freaks most people out is you have to stick your finger in to open up that chamber. And then you stick the tube in, and then he's actually applying a skin clamp to keep it in place. So we've sent, and the whole process, this is just a small snippet, but it's an oxygen saturation. So in the payload container contains an oxygen saturation, respiration, blood pressure, and then ultrasound of your lung. That's all been done in 11 minutes. And then the chest tube intubation, in theory, would be done either self-administered or you're a layperson helping somebody else, and then you'll save someone's life. So, and it does have a fully, as part of this grant, is it's building an accessible case or payload container. So the payload container will have colored bags. If you're colorblind, it also has different textured bags, labels, braille, and LED lighting for nighttime operation, with the idea that the physician, not being there, has to be able to very quickly explain what bag to pull for the ultrasound, what bag to pull out for the blood pressure cuff. Right? Everything's Bluetooth, so the patient, all they do is apply the blood pressure cuff, and they don't do anything. The physician actually starts and stops the blood pressure cuff, which is pretty cool. And that's about it. So obviously, lots of funders in these projects, so we have to give our thanks to all the funders, but I'm happy to have you guys come up and answer any questions.
Any questions?
Yeah.
Pablo, I'll know next time. Yeah.
It was a good song and dance, so you did good. Yeah.
We were worried about the rest of your slides anyway. They're all about your work with the City of Edmonton. I just want to say, yeah, thanks again. Thanks for being flexible. And I think, one of the things we talked about is, and Heather, we were already talking about it today too, is we almost want to have the reverse of today, where we have capstone students from an area within SAIT or Bow Valley College and say, here's 3, it could be a digital, it could be the VR lab, right? So here's 3 digital projects or opportunities that we're exploring with the city. How can your students come and do a capstone on that, right? And the other one, Pablo, with Alicia, we've also talked about, we'll have to show the strength of the concrete that we're printing. And you guys have a tensile strength tester, right? And so how do we start working together? And so, here's the products we're printing. Every time we change a concrete manufacturer, do we have to get it retested? Things like that. And how do we work together on some of those projects? Mostly to make it more affordable for us. But no, I think giving those opportunities. Okay, questions for SAIT? Yes, Sandra.
As usual. I have a question. You mentioned that you use Starlink in order to direct the drones into remote areas. Under what conditions could that signal be lost, and what would be your procedure to reestablish that signal?
Yeah, we're still using Starlink mainly for the communication between the client or the patient and the physician. Starlink, there's still too much latency using Starlink to control the drone, so we're still relying on radio signal. So if we use Starlink, we're looking at about a 3 to 4 second latency or delay. So if I turn the drone left, it's 3 to 4 seconds and you wait, right? And that's too long. So we're working with better latency reduction techniques to try to improve that operation, because that's the future. Eventually, it's going to be satellite-based drone drone navigation systems, in addition to the GNSS systems, the satellite locational satellites. And so radio signal is still the main focus. And we do have a number of different radio signal frequencies that we work with, like 2.4 and 5.8, and even down to 900 megahertz, as long as we get permission from ISED, who manages the frequency spectrum in Canada. And if we do lose connection, like let's say the drone is 40 kilometers away and we lose connection, it will stop and we can return home, so it can return home. So there are processes in place to make sure that the drone operates safely even beyond our eyesight, or if we lose the lost link. And we also have multiple, if we're going that distance and we're flying beyond visual line of sight, we have multiple optional landing spots. So if we do find that there's a problem with the drone and we don't have time to bring it back, we know where there are spots that we can safely land it. And we're not also flying beyond visual line of sight over the city of Calgary. It's usually remote, rural areas. Okay.
Great. Oh, we have one more, and then we're going to break.
We talked about the importance of like student integration, and I just wanted to lend also the importance of like professionalism for students. Do you know like if anybody is like ensuring that students are like, or the students' attitudes in capstones to like sort of offer insight? Because like for capstones, you're sort of forced to be in that class in order for you. So are there other ways that you're trying to integrate?
Well, yeah. Pass over to you guys for answers to that too. But I think it's a almost a multifactorial approach. So our instructors in the programs do a really good job of usually a communications course, or sometimes that's part of a project management course, and they focus on professionalism. They often have a proportion of the mark connected to professionalism with rubrics and matrix to understand what needs to happen, or if you are acting in a more unprofessional fashion, how do you improve that? And then we do more reinforcement because we already know that the faculty they're doing a great job. We bring them in and it's a different, faster paced environment. So we just reinforce a lot of those same principles. We just make sure that they understand that being on time is important. You know, the way that you carry yourself in a meeting, there are some ways that you carry yourself in meetings. And there's a long list of things, but we just more reinforce and give them feedback, and then they go back to the program, and hopefully by the end of the semester they're good. And when we do connect in clients, as part of their review of the student work, they also provide that indication as well. So they get it from the faculty, they get it from us as the research folks, and then they also get it from the industry player. You guys have anything else to add? No?
I just want to add, like the products that we provide to the clients, that we have the Apega kind of like the reviews that we do. So before we provide something to the client, we have a review process inside in our facility. So we have professional engineers in place, so they do the review. So it's a professional product that we are delivering to the clients. It's not the student work.
Okay, thank you.